Okay, hello and welcome back to my Project Euler series in Python. This is problem 8. So, largest product in a series. The four adjacent digits in the 1000 digit number that have the greatest product are 9989, which multiply to 5832. So, this is the 1000 digit number, I'm guessing. And the question is, find the 13 adjacent digits in the 1000 digit number that have the greatest product. What is the value of this product? Okay, well, we can take the brute force approach, which is just get every set of 13 digits and just keep moving it along, and try every single one for all, I don't know, there might be 986 or so, 987 or so combinations. And then, I don't know, that was a guess, but let's see if we can just brute force it, do all of those combinations, and then find the max. Because it only wants the product, it doesn't want the individual numbers, like it said in the first question, in the example. I'm still in editing mode. Let's print that. So if we just do some keyboard shortcut here, get this all on one line, and then we can do, I might just convert it to a string, just for simplicity purposes. I don't know, I'll call this the number. And what do we want to do with the number? So we need to go through. So if we print, I think strings are basically arrays, right? So arrays of characters. So if we print number 0, we should get a 7, right? Nice, okay. So it should be as simple as finding the maximum product of the four numbers. So if we generate every product of four consecutive numbers all the way through, and then just sum them up, and then just find the max, we should be good. So just trying to think of how we can do this as a list comprehension, because that could be quite cool, but maybe we'll leave that till the end, it might appear. So for I in range, let's call it 997. Then we want to append, if we just call this the products, and then we want to append dot append number I times, I know this is a little bit disgusting, but we're just going to have to go with it for now. Plus 1, plus 2, plus 3, and we're going to have to convert each of these to an int. Yeah, I can see this is already looking horrible, but bear with me, I might try and tidy this up afterwards. It's a relatively straightforward problem though. Reformat the file, that's nicely spaced out. So then we can just print products and print max products, and hopefully that is the answer that we get here. Okay, so this is brute forcing, and I really can't be asked to go and type that out 12 times. So let's do for j in range I to I plus 4. Well, sorry, I plus 4 because it's non-inclusive. If we just say product equals 1 for each new position, then product times equals the int value stored in number at position j, then products.append product should give us something that's about the same. Okay, nice. I'm not thrilled about this. From the file, there we go. So what do we do there? Well, we know that you're only going to be able to move this bracket of 4 numbers along 997 times, not all 1000, because if you did, then you'd go off the end, right? So we have to stop 3 short to include the last number, but nothing more. Let's just double check that this would cause an out of bounds exception. Yep, string out of range, nice. So if we go back to 997, so what we can do is actually call this like the number of adjacent things that we want, the product length, we could call it, and it equals 4 in this case. And we can just say like length of number minus product length. Okay, it's going to create an off by 1 error because this is non-inclusive, so I'm going to have to do a +1, I think, but then that should be fine. Yeah, and it generates the same thing, but then that means we can use the product length to give us this, and then we should be able to just change this to 13 easily enough. Okay, so we don't need to print the whole list anymore. This is still the brute force approach, but it's relatively tidy, so we can just change that to 13 and it should work. And this is our answer. So that is 23,514,624,000. Okay, let's just go. Spoilers, I've already logged in, and if we scroll down, 23,514,624,000. So yeah, we got the right answer. Just wondering if there's any way we could make this a bit tidier, but I don't know, because max is always going to be there. So it's going to cause the code to be a little bit more untidy, but the method would be tidier if we sort of kept a running total of the max and only ever stored that. And that would save the max function at the end. So we could do that. We could say max, that's a keyword, so let's call it highest equals, we could call it maximum, that might even, maximum equals 0, okay. If product is greater than maximum, then maximum equals product. So then we can just print maximum here. So let's just double check that gives us the same thing. Nice. Okay, so then we're not appending to a list every time. and we're only keeping track of the highest thing that we care about, we still do have to brute force it, and unless we do something really fancy like dodging zeros, which I think is just beyond the scope of the needs at this stage, then I'm relatively happy with this. So just to recap one last time, we have the 1,000-digit number, and we have a list of products which we actually no longer need, and our product length in this case is 13, but that's interchangeable to any number that you want to find the highest product for. And then we start with a current maximum of 0, so the first product that we find is going to then become the maximum, and so forth. And so for I in range, so that's the length of the number, which is 1,000, minus the product length, in this case 13, and then we need to add 1 so that we don't get that off by 1 error. So in this case it's going to be from 0 all the way up to 988. We can then set the product equal to 1 and then go and multiply every integer from our starting position all the way up to however many the product length is. So it's just going to keep multiplying on each next number that we find until we get to that product length. And then once we've got the product, we can check if the product is greater than the current maximum, and if it's a new maximum, then we set it to be that. And so once we've exhausted the whole list of all the numbers, we should be left with the maximum of the whole list. Okay, I hope that made sense, and let me know if you have a different way, potentially a better way of doing it, in the comments, and I will see you next time.